Hi, Math 1. This is Mr. Roberts at Shasta High School. Tonight's homework assignment is 95 through 100, and I've decided to record a brief lesson for two of the problems. One of them is 95, and I think I also am going to go ahead and talk about 97. So on 95, it says find the equation of an exponential function that passes through two different points here. One of them is 248, and the other one is at 750. We're given 2 points, and each one of these points has an x value and a y value. That's true over here too. There's a point with an x value and a point with a y value. And we're also fitting things. It says that it's an exponential function, right? So we've been working with this parent of exponential functions, y equals a times b raised to the x power. I believe this is the answer. We know that we've seen some errors in the textbook, but I think this is the correct answer. But the question is, how do I get that besides just writing it down? So what we're going to do is write a system of equations in which we plug in the x, y values that we have and create two separate equations. The first one that I would get if I'm using this first point, y is 48, and that equals a times b raised to the second power because x is 2 in that point. The other equation is based on this point, and it's 750 equals a times b raised to the fifth power. So what we've been doing is isolating, I think, a in one of the two equations and then plugging in that value of a into the second one in order to come up with the value of b. Once we know b, we plug it back in to figure out what a is. So let's go ahead and isolate a in this first equation, right? I'm going to isolate a in this equation. If I think about it, it's 48 equals a times b squared. If I want a alone in this equation, I'm going to divide both sides by two factors of b. I'm going to divide by b squared. On the right-hand side of this equation, I have a times b squared divided by b squared, which equals just a. So we've accomplished what we wanted to do, right? We now know that a, and I'm going to flip the order here equals 48 over b to the second power. So there's a value of a. Now that I know that this is a valid substitution for a, I'm going to plug that into the second equation. So this value of a is going to make the trip over here, and it was 750. We're going to write this equation again. It's 750 equals a, plain part of a is going to be 48 divided by b squared. That's my substitution. And then I'm going to multiply that by b to the fifth power. When I look at this, I can choose to think of b to the fifth as a fraction, b to the fifth over 1. And on the right-hand side, I can multiply numerator times numerator over denominator times denominator. So I'm going to multiply these two fractions, and I'll rewrite the 750 again. But I get the following. I get 48 times b to the fifth, and down in my denominator I have b squared over 1, which is just plain old b squared. So if I look at this, right, what I'm dealing with here is, in the numerator, b, 5 factors of b, and in my denominator I have bb. When I take the 5 factors of b, and I can write them all out, right, b, and then bb, and I divide by 2 factors of b, bb, I can see that there are 3 factors of b left over, so this is b to the third power. And of course there's rules for exponents, and we can look at those. If you have different exponents and it's a quotient, same bases, right, it's the difference in the exponents. I could see 5 minus 2 is 3. But just using the definition, I know that this has to be b to the third. So my equation is then 750 equals 48 times b to the third power. If I wish to get b cubed by itself, I'm going to divide both sides of this by 48. Divide by 48. When I do that, I'm embarrassed to say that I'm going to grab a calculator here, and I'm going to take 750, and I'm going to divide that by 48. And I get that should be, It's a decimal, that's okay. It's 15.625. So I have here 15.625, and that equals b to the third power. Now if I wish to solve this for b, I'm going to use the cube root. You can see I'm cubing b to the third power. I can undo that by taking the cube root of both sides. So this becomes b of the cubed root. If I take the cube root of the right-hand side and the cube root of the left-hand side, the cube root of b cubed is b. And over on the right-hand side, I have the cubed root of 15.625. So I'm going to bring my calculator over to help me figure out what that is as well. So I'm going to do this the long way. I'm going to do the method where I hit a 3, and then I hit math, and then I specify that I want a cubed root, or an x to x root, right? So I'm not going to use the cube root, I'm going to use the x root one. So I'm entering option 5, and so this is going to be a cube root, and then I'm just going to enter the 15.625. And what it gives me is the cubed root of 15.625 is 2.5. So I now know what b is, right? b is equal to 2.5. Evidently, if I take 2.5 times 2.5 times 2.5, I should get 15.625, and that's the magic. There it is. Okay, so we know what b is, and now the question is, in order to write our function, the last value we need to know is a. So let's come back out and zoom out of this thing here. So you can see that we now know our b, right? b is 2.5. Now we just need to figure out what a is. Well, I can see that this, whoops, that's jumping all around. This value of b we're going to substitute in here, and this will tell me what my a is. So a is equal to 48 divided by b squared, except for the fact that I know b squared is 2.5, so I'm going to go ahead and write 2.5 here and square that value. Again, I bring my calculator over, and I want to take 48, and I'm going to divide that by 2.5 to the second power, and that gives me 7.68. So a equals 7.68. At this point, I know both the values of a and b, so I can go ahead and take those values and plug them into the parent exponential function, and I get y equals a. Our starting point was 7.68. It's right here. Times b, which is 2.5, and raise that to the x power. So here is an exponential function that passes through both 248 and 5750.